BUCKEYE Science.
Alright, so I'm Mr. Joseph.
I'm Mr. Neil.
We are going to do some science videos for you guys on the COVID-19 extended break, we'll call it. So what we're going to do today is we're going to play around with the Woosh Bottle. A lot of you probably saw this in your grade 9 science class, and if you haven't, we're going to take a look at it right now. We've got a big bottle here. What's the size of this bottle, Mr. Neil?
The circumference of this down the base here is 90.5 centimeters. And the height going from the bottom up to the top of the curve or the top of the cone is 38 centimeters. And if you really wanted to calculate the cone, the volume of the cone, it's about 13 centimeters from the top of the cone to the top. Okay? So what we're going to do, we're going to ignite that. We're going to launch a roll of toilet paper.
Which is in high demand right now, we know. But no toilet paper will be harmed in this, we hope.
We think. The other thing is to think about this. This is the original invention, or the original idea behind the invention for the pulse jet engine. All right, that's something for you guys to look up. What's a pulse jet engine, and what does it do? But you're going to actually see it in action today.
And then what we're going to do after this, we're going to try and see how far we can launch this. Some of you might have seen this, that we broke a couple ceiling tiles this year. We're going to see how far this can go up in the air. After which, we're going to try and invert some of these Woosh bottles and see if we can use them as miniature rockets and see how far they go. So hang around with us and we'll do some of that.
All right, so we're going to have some fun.
Safety goggles on. Okay, so all we're using is ethanol in the Woosh bottle. We're going to coat that on the inside. Yeah, that hurt my ear. Yeah, good, I got my other ear that time. Ooh, it's a little warmer this time. Ooh, little singy. Alright, so experiment number 2.
You're a pepper.
Thank you. We're going to send Dr. Pepper here to the moon. So we're going to fill this with the ethanol, just like we did with the Woosh bottle. But now we're going to turn it upside down and light it from here. And we're just going to try something. We have no idea if this is going to work. We didn't put fins on it to stabilize it because we think the distance is too short that won't matter. But we're going to try and see how high we can get this in the gym here. That's experiment number 2.
And that's fins as opposed to Swedes, isn't it?
Yes, they're any Nordic type of person that you were a Scandinavian person you can put on the side there.
Attach them and away we go.
And then away we go. That was perfect. All right, so for this third one that we're going to try, we have a pop bottle attached to a toilet paper roll, which we're going to launch at an angle. I chose this one specifically because it had a tapered edge, kind of like a rocket nozzle. We'll see if that helps or not, but we're hopefully going to see this launch at an angle. We're going to put it at an angle going right towards this camera, so like this. We're going to see how far we can launch it in that direction. All right, safety goggles on.
Actually, he chose it because he's mellow yellow.
Oh.
They call me mellow yellow, quite rightly. They call me mellow yellow, quite rightly.
Yeah, it didn't really work.
That was it, eh?
That was it.
Well, we had a launch failure.
Yeah, the The bottle didn't really hold the ethanol and the flame very well, so no whoosh on that one.
It went poof. That was it.
Yep.
All right, well, that experiment's done. So what did we learn?
This bottle didn't really work so well. I think the mass was too high, or the propulsion wasn't enough, or it just couldn't get the flame out fast enough of this bottle, so it melted it instead.
So your curiosity question then to feed back to your teacher is, what do you think the problem was?
How do you fix the problem?
How do you fix it? You tell us.
Mm-hmm. So we're going to try again with a lighter bottle with a different shape. I have a feeling it's going to get the same thing happening, but we'll give it a try and see what happens. We got to jump.
Get it done.
Yeah.
No, I won't wait.
That's all. It's hot. I made a cloud.
Made
Again.
a cloud.
Yeah, we'll just leave it like this, though. We're not going to play with it again. We don't want to light more of the gym floor on fire. I mean, we totally didn't light the
We
gym
didn't do
floor.
that. We didn't do that.
It's only been on the tarp where we were good.
So now tell us what you think. It didn't work the second time.
That was great!
Okay, 6 meters.
Yeah. That's pretty good, though.
And what does the bottle look like afterwards? Completely melted.
That was even better. Dr. Pepper's the winner.
Awesome.
7 meters.
7 meters.
So minus
Minus
about 50, so be a little bit longer on that one.
Bottle's still intact.
Yeah.
Oh, that's fun.
That was great. So just to kind of set up the last thing, the last experiment we didn't really set up or explain, but what essentially we did was we used the 2-liter pop bottle. We had it nice and level. Some of them survived a little better than others, but we ended up shooting them down the hallway by having them fixed to a string and lighting it this way so it would propel that way, the bottle moves that way, and science happens. So anyway, science is over, so safety glasses off.
And we used the toilet paper roll too.
Yep.
That's
yep.
right.
We're using every part of the toilet paper now.
That's right.
We're not wasting any of it.
We launched it earlier, as we saw. A little bit of singe happening on it. And this time we got the bottles. We melted a couple in another couple of experiments. Mr. Joseph, you liked this one here, but we kind of melted it.
Yeah, kind of. The structural integrity I don't think stood up to it.
No.
I think they had something to do with the amount of ethanol in there, because this Dr. Pepper bottle, for some reason, withstood everything that we threw at it, but every other bottle just had nothing to do with it.
Maybe that's an advertisement for Dr. Pepper.
Yeah.
Drink Dr. Pepper.
But it might have just been coincidentally the amount of ethanol that we left in there. If we put too much or very little in the bottle, that might have helped basically preserve the bottle.
So it's a combustion reaction that's happening inside of it, right? And the byproducts are
CO2 and water.
CO2 and water. There's actually a little bit of water left in this from this reaction. CO2 we couldn't measure because, well, that's invisible. And maybe we will do another video in room 7 because there is a CO2 detector in there. And we have set off the CO2 detector by doing this reaction in there. So
we can see if that significantly increases it. The other thing you can look at for this is you can look at Newton's laws. In all of the experiments that we showed, Newton's first, second, and third law are obvious in there, or you can look for ways to connect those to what was going on. So that's another way you can look at this from a scientific perspective.
All right, I'll put up a slide when I edit this, just to give you the masses of all these, but I'll read them out as well. So our toilet paper roll was 116 grams, okay? And the wire mesh that it actually sat on when we launched that was 43.4 grams plus. We put some foil on there just to prevent this from being a flaming ball of toilet paper. So 46.9 grams of wire mesh and foil, so you can add those up together. And then our bottles here, a Dr. Pepper bottle that did a great job is number F, which is 49 grams. And we know that's a 2-liter volume. And the
A little bit bigger than 2 liters.
a little bit bigger. That you know, the liquid volume inside is measured 2 liters. This is also 49 grams, the Pepsi bottle that melted. And the water bottles we measured out, and it averaged out about 9.5 grams or so. And this one Mellow Yellow, they call you Mellow Yellow?
They do.
The one Mellow Yellow bottle is...
Ask your parents about that one.
kind of like Dr. Pepper
Yes,
commercial. Yeah. We're aging ourselves. Is 23 grams. All right, so
now, when we launched this, we kind of made a couple rough calculations. This one launched, when we launched it straight up in the air, had about an initial velocity of 8.3 meters per second. You can try and figure that out from the maximum height, which we thought was, I think we said 3.5
meters or so.
I will
That's right.
double check that and we'll put that in there. The other thing, and maybe Mr. Neal could put that in there, was that when this thing launched, the wire mesh went higher than the actual roll of toilet paper. So there's a couple of things that were weird that happened, but things that we were surprised about, but we were happy. Those were happy surprises.
They were fun.
Yeah.
Definitely, what did we estimate this one to be? About 11 meters or so that the toilet paper roll went up, and the wire mesh went a little further than that. And the distance that these pretty much went about the same distance.
Once we launched
six and a half meters.
for the final experiment, they both went about 6. This one went 6 meters. The Dr. Pepper one went 6.5.
Yeah. So
Yeah.
those were today's experiments. They'll be up for all of your science teachers to make use of. How they use them, well, that'll be up to them and what they do with that. So, anyways, that's it from us, I think.
All right. Thank you very much.
All right. Cheers, guys.
BUCKEYE Science.